Today's lesson is on the fundamental theorem of calculus and accumulation functions. So there's actually two fundamental theorems of calculus, and this is just one of them. So just to start out, some like little notation stuff. So what we've been working with this year is we might start with f of x, and then we take the derivative, and it's f prime of x. So now the idea is we're working in the other direction. Let's say we have f of x, and we want to take the antiderivative. We're going to call that capital f of x. And to be finding that antiderivative, we're essentially finding area under the curve of f of x. So in other words, integral. So here's that definite integral notation. So from a to b of f of x is telling you to find the area under the curve, and what that's doing is doing the antiderivative, finding that capital F of x. Now, the fundamental theorem that we're working with today is basically a statement that is saying derivatives and integrals are inverses of each other. So that means that they undo each other, just like subtraction would undo addition and division undoes multiplication. So they are inverses of each other, but now let's kind of put that into some notation. So let's say we have the integral from a constant to the function x. We're finding the integral of f of t dt. And now we're going to take the derivative of that integral. So essentially, these are canceling each other out, but what we do is we take this and substitute it into the function. So this equals f of x. And that right there is essentially the first fundamental theorem of calculus. And then in the next slides, we're going to look at kind of some variations of that. Okay, so I'm going to give kind of the general form, and then we'll do an example. So, derivative of the integral of a constant to a function, so of this function, f of t dt. So what this equals is, essentially what you're going to do is you're plugging this function into this function, so there's your f of g of x, but then you're multiplying by, it's kind of like chain rule, by the derivative of the function you are plugging in. Okay, so let's say we have the function that is represented by the integral from the constant 2 to the function 3x of 1 minus t squared dt. And then we want to find the derivative of that. So to find the derivative of that, I've got d over dx. So I'm taking the derivative of this integral. So we're just plugging this. We're basically replacing the variable with 3x, but then multiplying by the derivative of what we're plugging in. So this is equal to 1 minus 3x squared, and that whole thing is times the derivative of 3x, which is just 3. And you can simplify that. Let's see, we could do 1 minus 9x squared times 3. So 3 minus 27x squared. Okay, let's do one more example like that, and then we'll show the other variation. So let's say we've got the function f of x is equal to, so the integral from a constant to a function of this function, dt over 1 minus the cube root of t. And our goal is to find the derivative of that. Therefore, I'm taking the derivative of the integral, And I can rewrite this as 1 over 1 minus the cube root of t dt like that. And then now it's just a matter of plug this into the variable and then take the derivative of what you plug in. So equals 1 over 1 minus the cube root of x, and the derivative of x is just 1. So that's our final answer right there. Okay, so the other variation of this fundamental theorem is we're taking the derivative of an integral, and instead of from a constant to a function, it's from a function to a function, h of x to g of x of this f of t dt. So to find this, it equals, so if you plug in that g of x and then take the derivative of the g of x, and then we have to subtract if you plug in the h of x and multiply by the derivative of h of x. So at a quick glance, this looks super complicated, but it's actually not too bad once you see it in example right here. So if I have f of x is equal to the integral x squared to x, from x squared to x to the fourth of the square root of t dt, and then our goal is to find f prime, which means we're taking the derivative of the integral So first we're plugging in the top one into our function, then taking the derivative of what we plug in, and then subtracting, plugging the bottom one in, and then the derivative of the bottom one. So this is equal to the square root of plug in x to the fourth, and then times the derivative of that is 4x to the third, minus plug in the bottom one, the square root of x squared times the derivative of that, which is 2x. And this could be simplified, so that's x squared times 4x to the third, which is 4x to the fifth. And then this is just x times 2x, which is 2x squared. Okay, let's practice that method one more time, and then we'll be done with this video. So if I have f of x is equal to the integral from negative x to x of cosine t, can we take the derivative of that? So d over dx, take the derivative of this integral. Okay, so you start by plugging in the top one. So cosine of x, and then times the derivative of x, well, that's just times 1. And then minus, plug in negative x. So cosine of negative x times the derivative of that, which is times negative 1. So minus, but then this is a negative. This will turn into just cosine of x plus cosine of negative x. So there is your full video on this first fundamental theorem of calculus. It might seem kind of weird what we're doing, but we are kind of slowly unlocking all the pieces of that integral and idea of accumulation functions. Good luck with your lesson.